This talk is an advanced tutorial for administrators of HTCondor pools. In it, we will cover how submitters can be organized into groups, how users can be renamed, and how quotas can be enforced on groups. We assume here that you have a pretty good understanding of how the Condor Negotiator works, perhaps from the earlier Condor Negotiator talk. The agenda for this talk is focused on accounting groups. In HTCondor, there are two kinds of accounting groups, and we'll cover both. Accounting groups are the only way in HTCondor to put an upper limit on the usage of any user or groups, and we'll cover how to do that. We'll then talk about how to automatically assign submitters to groups. And finally, we'll talk about ways to move quota around groups if some groups are under their quota. The first kind of accounting group is what we call accounting group as alias. It lets one or more users change their submitter to a different or perhaps shared value. This is easy to accomplish. In a Condor submit file, to change your submitter to Ishmael, simply add the line accounting_group_user equals Ishmael. Make sure there's no dots in the value. No other configuration is required. This means treat this submitter as Ishmael for all HTCondor scheduling and accounting purposes. This is commonly used in web portal applications. Typically, a web portal runs as one operating system process, as one non-root user. As it accepts requests from the web, it creates Condor submit files and runs Condor submit as that one operating system user. However, it is doing this on behalf of real users who have authenticated in some way to the web server, maybe with a login and password or SSL or some other method. If the web app is responsible for authenticating, it can then set the accounting group user to that value, and HTCondor will treat those submitters as distinct. They will each get fair share among themselves, and the admin can set different priority factors and other things to bias the usage for each of them. In addition to creating jobs for different submitters, we can also go the other way as well. For example, if Alice and Bob are both logged into a submit machine as themselves, and they both set their accounting group user to Ishmael, HTCondor treats them as the same submitter with the same priority and same priority factor. There is no fair share, and all other things being equal, whatever jobs were submitted first will be considered for matching and running. Note this changes the submitter, but Alice and Bob are still distinct owners, and their jobs will never run as the Unix user Ishmael. The sandbox files, the inputs, the outputs, will all be owned by the Unix users Alice or Bob. No Unix user Ishmael will ever be created or used. So, the first kind of accounting groups are pretty straightforward. The second kind is a bit more involved. We call them accounting groups with quota. This is the only way to add a quota for a user or group. This brings up a bit of a terminology problem. If you look up the word quota in the Oxford English Dictionary, you'll see the definition is a maximum. Except, there is another definition under quota that is a minimum. So we always need to be very careful when we use the word quota. So the big picture about Condor quotas. Remember that before accounting groups or quotas, the HTCondor negotiator tries to assign machine resources from the whole pool to each submitter in some way that is fair, based on historical usage. Maybe an allocation might look like this. But with accounting groups with group quotas, what happens is each user opts into joining a group. In this example, maybe Alice is in group A, Bob and Charlie are in group B, and Danny is in group C. After each submitter is placed into a group, each of these groups gets a quota, which is an upper bound on the number of cores they can use. We'll explain in a bit how this number is generated. Then, after we have a quota per group, we divide the pool up into virtual subpools, each with a number of cores according to the group. Note that we do not assign specific machines to groups. Let's say group A gets 200 cores. We just mark that some set of 200 cores we don't know which ones, are owned to Group A, and some others set to Group B, and so on. So we might end up with an allocation like this. Then the negotiator goes through each group one by one and runs the whole negotiation cycle, as discussed earlier, constraining the size of the pool for each group and only negotiating for any submitters in that group. So, if Group A gets 200 cores and only contains the submitter Alice, then the negotiator negotiates for Alice with an upper bound of 200 cores. The Alice submitter is still a submitter in every way and is charged usage, and her priority is calculated in the same way. If Bob is the only submitter in Group B, the same thing happens, but with a different quota. Now, let's say Group C contains 3 submitters, maybe Danny, Edgar, and Fran, and they have a limit of 500 cores in the group. The negotiator tries to assign 500 resources to these 3 as if they were the only submitters in a pool of 500 cores. Resources will be assigned not first come, first serve, but in a proportional fair share way, weighted by historical usage and priority factor, just as normal. This is key. Even within an accounting group with group quotas, individual submitters retain their identities. This is completely different than accounting groups as aliases. How do we define accounting groups with group quotas? Well, each group must be predefined in the negotiator's config file in the group names parameter. If you add new ones, a Condor reconfig will cause the negotiator to reread these groups. Then, each group can be given a quota by adding a line per group with the key name of group quota followed by the group name. Accounting group names can be any string, but by convention, they all start with the name group underscore. The unit for these quotas defaults to core count, but in theory could be changed with the slot weight knob. Let's keep it as core count for now. Group quotas can also be expressed as a relative size or a dynamic quota. This means the percentage of the pool. This is done if the quota key starts with the group quota dynamic followed by the name instead of just group quota alone. This can be useful if the size of your pool changes or if you don't know how big it is from time to time. If the dynamic quotas do not sum to 100%, Condor then scales all the values so that it does. And just like with accounting groups as alias, jobs can opt in by a submit file setting. With accounting groups with quotas, the submit file entry is accounting_group equals group name. The order that groups are negotiated for can make a big difference when there are a few machines that are highly sought after. By default, the groups are negotiated for in starvation order. That is, the group that is furthest away from its quota goes first. But sometimes you want groups to have a strict first in, first out, or FIFO order. That is, you want one group to be able to get all of the pool, provided it has enough jobs, and only when there are leftover slots do you want the next group to go. A trick to do this is over-provisioning. Let's say that you know that your pool will never be larger than 10,000 cores. If you set a group quota to an absurdly high number, let's say 10 million, that group will always be the furthest from its quota, no matter how many jobs it has running, and thus it will always go first. But if that group does not have 10,000 cores worth of work, then the next group will go. And maybe you set that next group's quota to just 1 million, and so it will always try and fill that quota. Some organizations need this kind of FIFO policy. You can also override the ordering of groups manually by setting the group sort expr class add expression to evaluate the group add to a number, and the negotiator will order the groups by that number highest first. Many times, administrators do not trust their users to opt into getting their accounting groups. Or maybe you're worried about typos. HTCondor can now automatically assign accounting groups to submitters based on regular expressions in a map file. All you need to do is to set in the negotiator's config file the use feature AssignAccountingGroup and pass it as a parameter a path to a map file. And this is what map files look like. For historical reasons, the first column of the file is an asterisk. The second field is either the username or a regular expression enclosed in slashes that matches a username. The third field is either the name of the accounting group that we want to use for that user or a comma-separated list of accounting groups. If it is a list, then the user is allowed to select from one member of that list by putting it in the submit file in the accounting group setting. If the user does not specify an accounting group in their submit file, the first entry in that list is the one that's chosen. Obviously, if a quota is a limit on the amount of cores a group can use, should that group not have enough jobs, or if the jobs they do have do not match all the slots, then some cores will go idle. For many sites, this is the preferred situation. However, some sites will prefer that those cores are used by other groups in some way. Often, the first question administrators have after installing quotas and seeing them work is, well, how do we break quotas? In HTCondor, there are two ways to do this. The first way, and the way that we would recommend to most groups, is with auto regroup. This is very easy to enable. Just set group_auto_regroup equals true in the negotiator's config file. When this is true, all of the group algorithms that we discussed earlier work as usual. However, at the very end, after every group has gone, if there are any slots left idle, there is a bonus round where every submitter loses their group identity and negotiates individual, just as if there were no groups. All of the normal priority factor, and accounting still hold, but each submitter goes and negotiates as if there were no groups and no group quotas. This tends to work very well for most sites. The second way to break accounting group quotas is with surplus. This is a bit more work to set up, but allows for finer grained control. Surplus assumes there is a hierarchy of groups, with members of the hierarchy separated by dots. All members of this group quota hierarchy tree must be defined in the group names setting. The knob group except surplus must be set to true. For this example, let's assume there's a quota of 60 at the root, and a quota of 10, 20, and 30 cores in groups A, B, and C, respectively. And let's say that group except surplus is on. Let's assume there are just 3 cores of demand, however, in group A. This results in 7 cores of leftover surplus. These 7 cores are then reallocated to the peer nodes in the tree. These 7s are handed out proportionally to the peers in the ratio of the original quotas. So, group B would get a surplus of 3 extra cores, and group C 4 extra, for a total of 34. This process is then repeated recursively up the tree. HTCondor's quotas and accounting groups are not without their surprises or difficulties. In particular, because the group assignment code always goes before matchmaking happens, the group quotas don't know anything about what jobs might match which slots. If not every job matches every slot, we can get into imbalances between what we want our priorities and fair share to be and what they end up being. That is, if a group has a very high quota, but only has one job that matches any node in the entire pool, that group will still only get the one job running, no matter what their quota or priority may be. And with that, we are at the end of this talk. For more information, please check out the Condor manual at htcondor.readthedocs.io, or subscribe to the HTCondor users email list, whose subscription information is found under the main HTCondor webpage at htcondorproject.org. Thank you for your time, and I hope you enjoy using HTCondor.